So GM magnets, should I call people magnets? So GM people, welcome to another episode of our show. Um, my show basically. So yeah, last week I was going to talk about quantum computing, right? I'm just going to like what I want to do now. Like, the tuition I had now is that I want to just be teaching quantum computing. Like one episode I'll teach a new topic on quantum computing, then the next episode and that broader aspect of quantum computing then like that. That's why I planned about. So right now I'm going to like start from the basics, right? Yeah, from the basics. So last video I made a bold statement. I said that crypto was going to end, like the high prices we see now is going to reach to a time that it's going to be regulated. That means the price will not be volatile like that. The volatility is going to reduce massively, right? When crypto gets legality, because most of the price actions are being manipulated by bad actors and stuff. But now I want to like bring out a new spotlight on what will bring about that regulation, or practically like how would the bear run come? How would crypto die? You understand? So I've been doing some thinking. I've been thinking. So like now I put it to you now as viewers now. How will crypto die? Is it true? Um, Michael Silo and other whales dumping on us? Is it true? Is it by them imprisoning crypto influencers like Ansem and the rest, or is it by Binance and other big exchanges filing for bankruptcy like FTX? So most experts, and I'm quoting myself as an expert in this case, most experts predict that crypto is going to like crash as a result of quantum computing, right? And this is where I'm going to like enter right now. So I mean, with a quantum computer, you can break crypto. Like you can crack the cryptography used in blockchains. You can basically reverse a private key from a public key. Like you can reverse it. Like you can and still I can steal your coins. Like once I get your private key, I can steal your coins. So with the quantum computer, you can just like crack the cryptography used in protecting your private key. So I mean, that's what you can do with a quantum computer. So yeah, or simply put, sef, you don't even need to like I don't even need the private key. I can just use Shor's algorithm to get the cryptographic signature from. I don't even need the private key. Yeah, and when I have this your cryptographic signature, I can like access your wallets and make transactions. That one is even too hard, save. Better still, I can just like I don't even need to use a quantum computer. I can just prove that I have a quantum computer, and the whole market will crash. You get like I can just prove and the whole market will crash based on fraud, fear, and uncertainty, and like, the whole market will crash. So it's actually very terrible. And just imagine when something like that, when the quantum computer enters the hands of bad actors like North Korea. I mean, what would they do to it? North Korea that is like just nuclear weapons that they have, so they are like so that their negotiating power increase. Just imagine when they have a quantum computer and they can break down crypto. And China even hates crypto. Like Chinese government hates crypto because crypto is reducing their GDP very like very well. So they want to like they want to break crypto because in Chinese now it's not really like smooth to exchange their currency yuan for crypto, right? They have like ways they do it in China, like hidden ways. You understand? So I mean, once countries like this have access to economic computer now, they can break crypto, they can kill crypto. So that's just it. So yeah, moving forward. So um I just like said the dangers of a quantum computer, right? But it's not only crypto. You understand? A quantum computer can actually break cryptography of diverse infrastructure. I mean, your banks use cryptography. They use RSA. They use ethical cryptography. Like, I'm going deep, but I'll soon explain. So, I mean, just show you the risk. It's not only crypto markets. Is the broader ecosystem at large, like the world basically. So, moving forward, what is the quantum computer now? Like, let's ask the question: what is the quantum computer? What the hell is the quantum computer? I've been hearing quantum computers, quantum computer. What is the quantum computer? So I'm going to tell you what a quantum computer is. I'm going to like break it down for you to understand now. So basically, a quantum computer is just a computer on steroids. Like if you have seen an athlete that use steroids, like that use drugs, you see how like crazy they perform. That's how a quantum computer is just. A quantum computer is a very powerful computer. Right? Let me explain more. Right? Like now, classical computers or your normal computers now use um traditional bits, that is one and zeros. No, bits is like the basic information storage of the computer. So a classic computer use one and zeros now, but a quantum computer now use what they call quantum bits or qubits, and that qubits now can be in both one and zero state at the same time. They call it superposition, and I've explained it in series of my videos. If you check my YouTube, you see some illustrations there. But basically, that's just a quantum computer. A quantum computer is just more powerful. A computer that is more powerful than is a more powerful computer. You understand? So a quantum computer can be used in different, like it has different uses, right? It can be used in medicine, can be used in can help in drug discoveries and stuff, and material science. It can help in AI, faster AI, right? They have what they call quantum AI. You can do more further research, but AI, once a quantum computer and AI match together, poof, it's going to be crazy for the AI sectors, right? And a quantum computer can help in system security, right? Like most systems now, like all these cybersecurity experts now, they tell you that everything you know, or like your systems now use cryptography, you understand? So a quantum computer can help in the protection of systems. But like this comes with a twist, right? Just like it can help in protecting systems more efficiently, it can usually help in disrupting the existing system. I'll explain, right? A quantum computer now solves a problem that is infeasible for a classical computer. For example, now that's just basically what a quantum computer does. For example, now the reason your private key is safe is that for them to get your private key now from your public key, right? A classical computer now, it can take a classical computer millions of years to do that deciphering. But with a quantum computer, you can do it in minutes, in hours at least. You understand? So because of like you see that time discrepancy now. So yeah, if I have a quantum computer now, I can do this. Explain it, right? So basically that is just that's just the use of quantum computing. So moving forward, um now the problem now is that how will I put this now? The problem now is that since a quantum computer now can do this to crypto, what is the way forward? How do we make sure that how can we like prevent this? How can we like work towards not making this crash the whole system, right? Right? Not making this crash the whole system. So they actually have what they call post quantum cryptography, right? Like upgrading this normal cryptography now into the post quantum era. That is upgrading the cryptography into a cryptography that a quantum computer cannot decipher easily. You understand? Um, it's not as easy as it is. It's not like just upgrading your phone. Like just once you upgrade your WhatsApp just upgrade. No, no, no. It's actually more harder because this is like a decentralized ecosystem. It's not like it's easier for centralized systems, right? Like Mark Zuckerberg can just like tell you that alpha update. But in to upgrade a blockchain, you have to come to a consensus. You have what they call consensus, right? Like I mean, people have to vote. Like, should we do this now? Should we do this? So it's like a very very tedious process. Like, and it takes time. For example, Bitcoin is not quantum secure, right? Bitcoin uses electrical cryptography and classical cryptography basically. So to upgrades to a post-quantum cryptography, it's very hard. It's very hard because I remember the time that for Bitcoin to even upgrade, like for them to do the SegWit and Taproot upgrade, it took 3 years each from the intuition of the idea. It took 3 years of decision making, of coming to a consensus. And now, like you assume, okay, why can't we just like make wait 3 years because the current computer is not here now? You understand? So now it is that 3 years is actually a very short period of time because if you check, um, companies that actually produce quantum computers like IBM, Getty, Psyquantum, like they have roadmap, and the roadmap, the list I'm seeing is that the time for a quantum computer should be mainstream. For a quantum computer to be mainstream is like 2030. That is like the highest, right? So, and then looking at we are 2025 now. Looking at the time Bitcoin is going, let me say they take like maybe 3 years to reach a consensus. They also take time to like design the cryptography. Like you have to write the code again. Like that's the another tedious process on its own, right? Then you still have to convince other people to migrate, like to change their wallets. Like other people, you have to like announce it. Like you know, and worst thing is that people will not still know. There are some dormant wallets that they don't even know what's happening now. They will lose their crypto because once you upgrade the cryptography, everything now is invalid. You understand? So people usually lose their crypto. You understand? So it's just better for you to just look like keeping your eyes up and doing. So the timeline now is very very short because I'm projecting like for Bitcoin to migrate to a post quantum era to take like 4 years, and plus other the users like the normal users that don't really understand technicalities of Bitcoin to take another time and they have like risk of losing their crypto. So you see how like scattered everything is. That is because it's decentralized, right? So the safe bet now is for you to just like, okay, since I know this is the problem, there are some projects that they see this as a problem, like they see this as a huge problem because the Bitcoin community don't see this as a huge problem right now. They're like, let's don't migrate, let's keep it there because if we try to migrate to a post quantum era, you can dump the markets and stuff like that. Let's just wait till the economic computer is more feasible. You get. But there's some people that are like, no, this is an issue, right? This is a fucking issue. We need to find a way to solve this problem. And then they built their own post-quantum blockchain, right? There's plenty. There's QRL, there's Cellframe, there's QEVM, plenty, right? And there's a whole like new ecosystem. And the reason why I'm not seeing them is because they use a different dex. They use different. They don't even like. You cannot see them on. Okay, yeah, some of them are already listed. You understand? So yeah, that's just basically it, right? I don't want the video to be long. Let me summarize what I just said in this video. I explained the quantum computer. I explained very very shortly how a quantum computer a quantum computer is a threat to crypto, and yeah, and then post quantum era and stuff like that. So my next episode I will go more deep into quantum computing, and yeah, I might talk about quantum algorithms or quantum neural networks, or basically how the spirit leads. So yeah, this is a wrap up for today. I don't know. I mean, okay, this is like 30 minutes video. So shout out, small. I'm upgrading my setup, right? I'm upgrading my cryptography, my setup, and yeah, before you know, we'll be producing high quality content. But for now, that's how it is, right? Shout out to you. Link up to you. Stay safe.